Hello, my name is Henry Gorilla, and today I would like to talk with you a little bit about a popular quantum physics idea known as string theory. I'm currently a student enrolled at Missouri State University, and I personally think that string theory is a very interesting concept in the world of modern science today. For a couple of reasons. The first being what string theory would imply if proven true. It would drastically change the way that we perceive our physical world around us. Second, the history of string theory in and of itself is quite interesting as well, as it has been a heated debate topic over science for the last couple of years. So let's start by saying that when learning about string theory, it's very important to keep an open mind. Generally, what string theory tries to do is explain the unexplainable, unite the worlds of what we can see with our eyes with the world of what we cannot see because it is too small or too large. So what is string theory? WiseKey.com states that string theory might very well have been the unification field that Einstein sought before his death. Brian Greene from WorldScienceFestival.com states that the general purpose of string theory is to unite the worlds of quantum physics, the infinitely small, with general relativity, the world of the infinitely large. So how would it do this? Well, back in history, scientists used to believe that at the core of all subatomic particles, we would find a singular point. What string theory is idealizing is that at the core of all subatomic particles, we would find a vibrating string of energy, looking somewhat like this. It would be a one-dimensional object in a single point in space, or a single point on a piece of matter in the core. Superstringtheory.com states that the way that these strings vibrate would determine everything. Just as a guitar string is plucked on a guitar, if it is high, then the pitch will be up on the neck. If the tone is low, then the pitch will be down on the neck. So, it is thought that these core strings literally make up and determine the behavior of every matter and particle in existence. So while this seems to be the perfect answer of linking the worlds of small and large, which seems to be the problem in modern science today, as the world of general relativity differs so much from the world of quantum physics, there is still a couple of problems. Some scientists in the modern world seem to think that string theory is somewhat of a hocus pocus, partially because there is really no way to prove its validity through experimentation, as science isn't adept enough to go that small, but also because the way it evolved. So let's look at that. The history and the evolution of string theory began in the late 1960s when a researcher named Gabriele Veneziano at a European Particle Accelerator lab stumbled upon a mathematical formula called the Euler beta function, which looks a lot like this. That right there is basically the formula for string theory. Now, ThinkQuest.org states that this function seemed to describe many of the properties of nuclear interactions of elementary particles, and they were modeled as one-dimensional strings instead of the zero-dimension point that had been thought of before. So this would be debated for quite a while, but eventually, in the 1980s, string theory had evolved and formed a new concept. This was called superstring theory. Now, AstronomyCafe.com states that superstring theory fixed many of the mathematical anomalies and problems that basic string theory caused. Superstring theory suggested that these strings vibrate in different dimensions of space and time. These different dimensions would weave in and out of each other, kind of like this diagram here shows how these strings would interact with space and time. It's a very difficult concept to understand, I know, and it's only a basic description of it but it was a revolutionary idea at the time. Um, and many scientists to this day, however, are still highly skeptical of the theory because there is no way to prove that these strings exist. Peter Voigt from AmericanScientist.org writes that string theory not only makes no predictions about physical phenomenon at experimentally accessible energies, it makes no precise predictions whatsoever. While string theory cannot be proven or disproven as of right now, it can still be seen as a landmark idea in quantum physics and science as a whole. We as human beings seem to ultimately want to know where we came from, where we will end up. Many quantum scientists believe that string theory is the solution for this. It's the way to link the small with the large. Although the history of it over the years has been used for some kind of debate, and even the way it was found was generally misunderstood, it can be agreed that it is a very interesting concept in modern science today, and we will see where it goes in the future. Thank you, and have a good night.